Hello all, and welcome to my final presentation. After talking about the sleep-wake cycle earlier in the session, I was inspired to dig a little bit deeper, so I would love to talk to you today about dreaming theory and the neurobiological mechanisms that underlie it. Today I would like to discuss understanding the neurobiological regions of the brain and comparing brain activity when awake versus asleep. I would like to explore theories for why we dream and also discuss questions to consider moving forward. So, according to Nur et al., there are two broad regions in the brain that show activity during dreaming, primarily talking about REM sleep: the posterior parietal area and the ventromedial prefrontal cortex. The posterior parietal area is correlated with spatial and visual imagery in dreaming, while the prefrontal cortex takes on a role of inhibition, reducing the sense of self-awareness and producing atonia, which is lack of muscle tone and tension. Importantly, both of these regions have a strong connection to the limbic area of the brain, which is responsible for memory and emotion, and this is where the narrative content of dreams is proposed to arise from. Next, I would like to direct your attention to this beautiful image of a brain provided by Lamphros and Schwartz. In the pink are areas of the brain that show activity in both an aroused and dreaming state, while in the blue are areas which are active in an aroused state but show inhibition when dreaming. So there are three primary regions of the brain that show activity in arousal and dreaming, and these are the occipital temporal area, which is responsible for visual images and processing, the anterior cingulate, or and the MPFC, the medial prefrontal cortex, which helps with the vividness and intensity of our dreams. And last, we have the limbic area and the VTA, which is responsible for the emotion and memory processing. There are also two areas which show activity in arousal and inhibition in dreaming, so they differ. And these are the postcingulate precuneus, and this is and the dorsolateral prefrontal cortex. These both contribute to reduced executive function, reduced time perception, and a deficit of insight. So, now that we've talked about the regions of the brain involved, and the similarities and differences between the sleeping and the waking state, I would like to discuss a few of the theories on why we dream and the connection that these share with specific areas of the brain. So first, according to Scarpelli et al., we have the continuity hypothesis. This hypothesis explains dreaming as somewhat continuous with waking thought. Is supposed to help with incorporation and the processing of daily experience. This theory is strongly based on the activation of the default mode network, primarily located in the cingulate cortex, the MPFC, and the hippocampus, and this has been proposed to have a connection with recalling previous experiences and also story comprehension. Contrary to this hypothesis is the activation synthesis hypothesis, which was promoted under the belief that dreaming is random, mainly stimulated by the brainstem, specifically the pontine region. The pontine region is predicted to initiate REM sleep, which then stimulates limbic areas, triggering emotional content and memory in our dreaming. And then this triggers the cerebral cortex, which attempts to interpret this information, which results in a narrative. This method essentially purports that dreams are meaningless. They're basically just an attempt of the brain to create a narrative from random neural activity. Thus, both theories account for the activation of brain regions during REM sleep, but they differ in their interpretation of what this activity signifies. Continuity infers a continuation of waking life experiences and having connected meaning, while activation synthesis implies a more fragmented, nonsensical interpretation of dreaming. Continuing further in the research from Scarpelli et al., I want to talk about where do we go next. Looking further into the continuity hypothesis, many interesting questions arise with room for further study, such as lucid dreaming and the positive effects that it has on addressing chronic nightmares and improvement in mood regulation. Lucid dreaming is shown to activate certain areas of the dorsolateral prefrontal cortex, which increases self-awareness and attention so that the dreamer can see themselves in the dream. This, if the continuity hypothesis is on the right track and our brain is working on consolidating and arranging information while we sleep, do association and memory become looser overnight? Could dreaming have an active role in forgetting, primarily by replaying recent experiences in the hippocampus, promoting long-term potentiation? If this were to be true, what possible implications could this have for future therapy methods? Clearly, there's a lot more to this topic. Thank you for listening to my brief introduction today.